another project from 21 and 21. 21 projects in 21 days. This one is the final project in the Azure series. So we've done building a basic streaming backend on Azure. We've added AI moderation. We've added the ability to handle streaming events at scale. Now we're going to deploy the app with Azure DevOps. So relatively similar to the GitHub Actions workflow that you might be familiar with, but yeah, this time just in Azure instead. And there's a few other unique characteristics about this that are useful, especially if you're working in Azure. With things like the function app and then Cosmos DB and whatnot, whatever else, Azure services you're working with, they integrate really closely with this. So yeah, super cool project. Cool. So we're going to deploy your streaming app with Azure DevOps. And that looks like creating a production-grade deployment pipeline like Amazon and Netflix. Build multi-stage workflows with staging environments, approval gates, and automatic rollback. So this is a mildly spicy project. It's relatively difficult. If you've done the other three, you should be fine, but it is a bit to do. And we've got the 4 related projects, or 3 from the series in this one. Key concepts: Azure DevOps, Azure Functions, and GitHub Actions. So a quick 30-second summary. You've built a streaming backend with Azure Functions, AI moderation, and event workflow, but how do you ship updates safely? You could deploy manually, hope nothing breaks, and fix issues when users complain, or you could deploy like the tech giants do. Amazon deploys 136,000 times per day. That's 1.6 deployments every second. Netflix runs over 4,000 automated pipeline steps for every single change. MetLife cut their build time to under an hour and catches 15% more bugs before they reach production. They all use CI/CD pipelines, automated workflows that test code, deploy, staging, wait for approval, and then deploy to production. If something breaks, they roll back in seconds. New team members can ship code on day one because the pipelines handle risky parts. You'll build the same production-grade workflow with Azure DevOps, connecting your GitHub repository to a multi-stage pipeline that deploys your streaming backend safely. What you'll build: you'll create a production-grade CI/CD pipeline using Azure DevOps that automatically tests, stages, and deploys your Azure Functions backend. Why does CI/CD matter? Manual deployments are terrifying. Did you remember to run tests? Did you deploy the right version? What if something breaks at 2 a.m. on a Saturday? CI/CD pipelines remove the human error from deployments. Companies like Amazon, Netflix, and MetLife don't deploy manually. They never survive at that scale. Instead, every code push triggers automated tests. Passing code deploys to staging first, where engineers verify it works. Only after approval does it reach production. If production breaks, they roll back in seconds, not hours. This project teaches you how production teams ship code safely. You'll build staging environments, approval gates, and the confidence to deploy any day of the week. Cool. So if you want to check if this project is right for you, you can click here and use the Ask feature, the AI here, and it will go and respond to you. So how you'll build it: first, you'll set up Azure DevOps and connect it to your GitHub repository. Then you'll create staging and production function apps with separate configurations. Finally, you'll build a multi-stage YAML pipeline with approval gates. This is sort of an outline here. You've got the automatic, so you push automatically it will go through this check here, build a test, deploy to staging, integration tests, and then deploy to production if you give a manual approval. And then we've got a staging and a production environment. Cool. So by the end of the project, you'll have an Azure DevOps project connected to your GitHub repo, staging and production function apps, a multi-stage pipeline that runs tests, deploys to staging, and then deploys to production. And the second mission is automatic rollback if production health checks fail. Prerequisite, this project builds on serverless AI on Azure series. You'll need a working Azure Functions app project in a GitHub repository to deploy through the pipeline. If you haven't completed the earlier projects, you can still follow along. You'll just need any Azure Functions code in a GitHub repo. So if you're up for a bit of a challenge, you can do this quiz now. I'll do it at the end. And then in this video, we're going to be walking through the step-by-step guidance, but there's some guidance, and on your own tracks you can go down if you feel like it. Cool. So before we start step one, in this project you'll build a production-grade CI/CD pipeline using Azure DevOps, where you can automatically build and test your code, deploy to staging, use approval gates, ship code confidently. So I'm going to build it. In this project, I'm going to build a CI/CD pipeline to test my code. CI/CD is important because it means humans are not left to track small errors. We ship code confidently. Azure DevOps helps me deploy my code with Azure. Deploy and check my code with Azure. That is tied to Azure services. Cool. So what are we doing in this project? In this project, I'm going to build a CI/CD pipeline to test my code on every push. CI/CD is important because it means humans are not left to track small errors. /code quality. And thus we can ship code confidently. Azure DevOps helps me deploy and check my code that is tied to Azure services. Cool. Step one, connect Azure DevOps to your code. Time to set up Azure DevOps and connect it to your streaming backend. This is where the magic starts. You'll create a project, link your GitHub repository, and set up separate staging and production environments, just like Amazon and Netflix do. In this step, get ready to create an Azure DevOps project, connect your GitHub repo, create staging and production function apps, configure environment variables for both stages. In this step, I'm going to set up a Azure DevOps project. Connect to my add environment variables. a self-hosted agent is agent that runs on my local machine. We'll be using a local agent to run the DevOps pipeline because Microsoft, who run Azure, have a 3 to 5 day wait time for them to approve use of something we'd like to use, so we're just going to be running it locally. Makes no real difference. It just means you have to run a quick installer before we get started for that, but that's all good. So in this step, I'm going to set up an Azure DevOps project, connect my GitHub repo, add environment variables to a new staging functions app. And then a self-hosted agent is an agent that runs on my local machine. Cool, so we're going to check out prerequisites. This project builds on the previous projects in the Azure Functions series. Let's make sure you have what you need. So if you need to start from scratch, there's information here. If you've just completed part 1, there's information here. If you've done parts 1 and 2, not 3, there's information here. And then if you've done all 3, which I have, then you should have a working Azure Functions app in a GitHub repo, an Azure subscription with function apps deployed, Cosmos DB with messages, violations, analytics, and stats containers, AI moderation with Gemini integrated, durable functions with a fan out / fan in orchestration. And yeah, that should all be here if you've done these projects. Cool, so we're going to create a Azure DevOps organization. Cool, so I'll just open this in my other browser. That's where I log into Azure. On the side. Cool, so I'll just search for Azure DevOps organizations there. Click view my organizations. I've already created an organization on this account, so that's why I don't have a screen to fill out these things, but you likely will if you haven't. No, there you go. W L6Y V. Cool, sorry about that. I had to delete an old organization that had the same name. Cool, so we'll call the project inside the organization streaming backend CI/CD. Click create project. We should see a new project dashboard pop up. Nice. So what is Azure DevOps? Azure DevOps is Microsoft's platform for managing software projects. It provides tools for source control, CI/CD, pipelines, project tracking, and more. In this project, we're using Azure DevOps pipelines to automate deploying your code, whether you push changes to GitHub, whenever, sorry, not whether. Cool, so we're going to set up a self-hosted agent. Azure DevOps pipelines need an agent, a machine that runs your pipeline steps. Instead of using Microsoft's hosted agents, which require approval for new organizations, you'll create a self-hosted agent on your own computer. This works immediately with no waiting. So we'll head down to project settings. So agent pools. We'll click select self-hosted, which you call it default. Grant permissions to all pipelines. Actually, I've already got one called default, so I'll call it default new. So we'll select your operating system, new agent, and we'll select the operating system you're working on, and then we'll click download here to install the download the installer. This can take between 2 and 5 minutes to install, download, sorry. So we'll just wait for that. So I'll just click and save this to my desktop real quick. I think that worked. Let's look. Cool, so I will just actually put it here so we can see what I'm doing. So I just extracted the zip file that was downloaded. And now we have this, so it's cool. Now we'll open the space in the terminal. We can run config.cmd. Okay, give me a second. Sorry, it was just because I was already logged in. So I'll just go through the log. Oh, I ran. You won't need to do this, but I was already logged in. So I just ran config cmd remove. Cool. So yeah, we'll put in our link, which I already knows from me. Authentication type, we need a PAT. We can go get our personal access token. So if I jump back to this, I can go into here, I can click the 3 dots, user settings, and then personal access tokens. I will blur this. Well, won't blur, I just want to put it on my screen. So scroll down, you can click personal access tokens, click new token, do a name, you do agent setup. And then tick full access and then click create. Cool, so I've got, can't see my whole token there, but paste that in. Okay, that's because I was just confirming. Oops. Confirm root. Okay, utmost apologies. I had to delete a config file, but I didn't know I had to delete it. So I deleted that, and now we can enter our server URL from the start. So I think that'll be this. PAT, and then that in there. it's just selecting these settings there. So that's all working, all configured. And if we can run it, I should say listening for jobs. The server, listening for jobs, cool, okay. So now we've got to keep terminal open because this is effectively the server we're running everything connected to, so the pipeline we're going to run in a minute. Yeah, and if we want to, we can go back to in pools. Yeah, cool. It is connected. We don't have an agent here. It's not going to say it is running or online. What is a self-hosted agent? An agent is simply a machine that runs your pipeline steps. Microsoft offers hosted agents, their service, but new organizations need approval to use them. A self-hosted agent runs on your local computer instead, connects to Azure DevOps, picking up pipeline jobs and runs them locally. This gives you full control and works immediately without an approval process. Upload a screenshot of your Alex. So we'll just go here. Oops. Declare the end. What does a self-hosted agent do? I configured my agent by running the config script and entering an access token. The self-hosted agent runs pipelines on my local machine instead of a remote cloud server. What does a self-hosted agent do? I configured my agent by running the config script and entering an access token. A self-hosted agent runs pipelines on my local machine instead of a remote cloud server. Cool, so now we're going to connect our GitHub repository. Now let's connect Azure DevOps to your GitHub repo. First, we need to push your GitHub code to GitHub if you haven't already. Cool, so we'll select GitHub connections. So connect your GitHub account. I'll select this one. We can add the streaming backend here. I need to verify by email. I'll just get that. From my inbox. Cool, so we have that link, that's good. Yeah, so if you don't have the repo set up, you can go to this. So my code is already on GitHub, but if it isn't, you can go to this link here You can call, oops, name your GitHub repo that, I already have one of this, but make sure your visibility is set to private. You can, once you click create, you'll be given this. You can copy your URL into there. You can go to cursor, navigate to the streaming backend folder you have on your local machine, and then run these commands to initialize and then just push everything, or add and then push everything. You should see this in here. Yeah, and if you haven't done, or if you have pushed it to GitHub, that's completely fine. You don't need to, yeah, if you have any recent changes, then do that, but yeah, you don't need to do anything of so. So what is a service connection? A service connection is a secure link between Azure DevOps and an external service like GitHub or Azure. It stores credentials so your pipeline can authenticate without exposing sensitive tokens. Once connected, Azure DevOps can access your code and deploy your cloud resources. I'm going to create a staging function app. You already have a function app in the previous projects, but and that'll be your production environment, but we'll need a second one for staging, which is just testing. So why staging in production environments? Staging is like your dress rehearsal environment. It mirrors production but isn't used by real users. You deploy to staging first, run tests, and verify everything works before touching production. The safety net catches bugs before they impact your users. If staging breaks, no one notices. If production breaks, everyone notices. Cool, so we'll go to our Azure portal here. We'll click create a resource. We'll select create a function app. We'll select flex consumption. We'll select our existing resource group. Give a new function name indicating staging. Okay, we can move this. Just one underscore. Let's see if that works. Cool. Select Python. Cool. Click review plus create. And then click create. Cool, so now that'll deploy. If you have a quota or a subscription error, there's some steps here. Yeah, also definitely feel free to reach out to the community or use our ask feature over here. Your existing streaming backend function app from parts 1 to 3 will serve as your production environment. You now have 2 function apps. One for testing deployments, one for the actual production environment. So now we're going to configure this function app once it's deployed. We can go to, set up the, here goes deployed. Go set up all the environment variables for it. So first we'll go to Cosmos DB. Go here and we'll go to keys, settings, keys. Primary connection string. It's important you're getting this, not this CRI at the top. So we'll go back to our Functions app. We'll go to settings, environment variables, add, paste in that there. We'll call it Cosmos DB connection. I might also delete this old thing I was using for testing here. So I'm going to start with this. Cool. Okay, so now we'll go to our AI Studio from Google, and we can get our left sidebar. We can select, kind of in the right spot because I was logged in, but go to Get API Key, click the API key, and then we can click Copy. Again, we can go back to the environment variables here. We can click Add, put a value in, and then update it to be Gemini. Then we can confirm. Why copy the same settings? For this project, we're using the exact same Cosmos DB for both staging and production to keep things simple. In a real production environment, you typically have separate databases for each environment to avoid test data mixing with real user data. Portal checkpoint. So if you want to go check Functions app, you can see both these being the same. So function apps have the same set of environment variables. Welcome to, you should see something like this, which is what we do, so that's good. Just take a screenshot of this. Why do we need separate staging and production environments? I created two function apps. Staging app and a production app. Staging app is for testing before everything goes to production. Production's for our users. I configure environment variables so that both function apps have access to the same environment variables. So why do we need separate staging and production environments? I created two function apps, staging app and a production app. The staging app is for testing before everything goes to the production, and production is for users. I configured environment variables so that both function apps have access to the same variables. Cool, so step 2, we're going to build your multi-stage pipeline. So now for the main event, building a multi-stage CI/CD pipeline. This is exactly how Netflix orchestrates over 4,000 automated steps per deployment. You'll create a pipeline that runs tests, deploys to staging, waits for approval, then deploys to production, all automatically triggered by a simple git push. In this step, get ready to create the Azure Pipelines YAML file, configure multi-stage deployment, set up approval gates before production. what are we doing in the step? In the step, I'm going to create YAML config file. Well, config for the pipeline using YAML to define multi-stage deployment. The 4 stages are there'll be staging, production, testing, test, deploying, staging, approval. All right. Not in the right order, but whatever. What are we doing in the step? In the step, I'm going to create a config for the pipeline using YAML to define multi-stage deployment. The 4 stages are staging, production, testing, and approval. Cool. So create a pipeline YAML file. The pipeline is defined in a YAML file that lives in your repository. You'll build it in 4 cursor prompts, 1 for each stage. This helps you understand what each part of the pipeline does instead of copy and pasting a giant YAML file. Open your streaming backend project in Cursor, create a new file called Azure YAML in the root directory, and open Cursor chat. So I've already got Cursor open over here. So I'll just select here. I'm going to open it from my desktop. So I'll create a new file called Azure pipelines.yaml. Open the Cursor chat either with this or the Control L shortcut, and then we'll send off this prompt. So what's happening in this prompt? This prompt creates the pipeline foundation and the build stage, where to trigger, which agent pool to use, your self-hosted agent, variables to reuse, and steps to install dependencies, run tests, and publish results. Cool. Yeah, it's super important we specify that it's running on our local machine, because that's that's required for what we're our current setup. Why that there you go. Shouldn't take too long. Cool. So sending off the next prompt. What's happening in this prompt? This creates the deploy to staging stage, which only runs at build passes. We use Azure CLI 2 with functions, Azure Functions app publish instead of Azure Function app 2, because it works better with flex consumption function apps that we have. Just send this next one off. The deployment job type tracks deployments and can require approvals. What's happening in this prompt? This prompt creates the integration test stage, which verifies your staging deployment actually works by hitting the health endpoint before allowing production deployment. Cool. So yeah, obviously it's important for us to understand that our services are up and running using a health endpoint there, checking it's good before we go and push to production. Because if it was unhealthy, then we certainly wouldn't want to push to prod. Cool. So what's happening in this last prompt here? This creates the final stage the production environment requires manual approval before deploying, so a human must review code before it goes live. What does this pipeline actually do? Build, so installs Python, installs dependencies, runs tests, and publishes test results. Deploy staging, deploys your code to the function app after the build succeeds. Staging, integration tests, runs health checks against staging to verify deployment works. Deploy production, deploys to production after integration tests pass and manual approval. The trigger -main means the pipeline runs automatically whenever you push to the main branch. The depends on and condition settings ensure stages run in order and only when previous stages succeed. Cool, so it looks like it's finished. Just a screenshot of this YAML file or part of it. Cool. So what does each stage of your pipeline do? My pipeline has 4 stages. Build does Python install. Can't remember what else it does. Dependencies. Deploy staging does. Code passes. These tests to the staging branch. Code is ready for production. And deploy production. Deploys the code to the production. Oops. Cool. So let's push the stuff to GitHub here. So I'll open up a new terminal. Actually, I think this might, yeah, I need to re-auth my Git. 1 second. Okay, cool. I have logged in. And that seems to have worked now. We can check the GitHub repo, see if it updated the YAML like we're trying to. So we're going to configure Azure Service Connection. So the pipeline needs permission to deploy the Azure Function apps. Go to the Azure portal, search for Azure DevOps organizations, same way we did in step 1. This as a project settings. We'll go to pipelines, one of these, yeah, pipelines. We might need to go just project settings and pipelines. Yeah, service connections. So click create service connections. Yeah, so we'll just select Azure Resource Manager, click next. Should log in fine. Cool. So we'll select our subscription, select our resource group, service connection name, cool. Hopefully this works. What is a service principal? A service principal is like a robot identity for your pipeline. Instead of using your personal credentials, which would be a security risk, Azure creates a dedicated identity with limited permissions. This principal can only do what you allow it to do. In this case, deploy to your apps function, or to your function apps. Set up environment approval gates. So we move on to step 3, ship code like the tech giants. Time to see your pipeline in action. This is the moment of truth. You'll trigger a deployment, watch it flow through each stage, approve the production deployment, and verify everything is live. By the end, you'll understand why companies like Amazon confidently deploy 136,000 times per day. In this step, get ready to create the pipeline in Azure DevOps, watch the build and staging deployment, approve the production deployment, verify production is live. What are we doing in this step? In this step, I'm going to run a build pipeline by triggering by pushing code to GitHub, or nearly running the pipeline and approving the code changes. Cool, so we've got a pipelines, test plans, pipelines, click create pipeline. We'll select GitHub as our thing, and then select the repository as streaming backend. It's picked up our YAML file, which is good. And now we should be able to click run. Cool, so we can see it's opened up there. If we go to I wonder if I did. I'm not sure this will work immediately because it's, I think I left Wi-Fi, so it says, or something happened, so agent has reconnected. But we'll see. If it doesn't work, then I'll just restart the agent, that's fine. Cool, so we asked to permit a few things here. So we'll permit that, and then it should start. There you go. Okay, cool. So I don't need to restart. It says build and run tests running that job. Cool. So this will take a bit of time the first time it runs through, because it's got to install Python and a few other things on this, on what's testing it. So yeah, this can take, especially the deployments, can take a bit of time, but that's all good. I think that's fine. Oh, never mind, it's an error. Okay, let's have a look. It looks like cursor has produced some invalid syntax. So what we'll do is we'll just copy this into cursor, and we'll say it should fix it. And then we'll have to push again, and then the deployment should restart. Sorry, the pipeline should restart. Cool, so I'll let it finish, and then, cool. Right, so we can open a new terminal, add all, no more changes. Update the YAML, and then we can push again. Cool, so you can see there, it's trying to build again. Cool, so this is actually fine. It's just a warning there. There is an exit code, but I think that'll be okay. If not, we'll just go back and fix it again, but we can grant permissions for that, see if it's actually going to continue. I think we'll see in here something which says, yes, succeeded with errors, with issues, sorry, that's okay. Yeah, so this deploy to staging will probably take 5 minutes or so to go through, because there's quite a bit to set up and install, and then it's got to run the commands that we've set up. That's the second permit we had to do. So yeah, we'll just wait for this to deploy. It's almost finished deploying. Yeah, we'll get some permits we'll have to accept there. Send a screenshot of this running. What's happening is your pipeline runs. My pipeline is progressing through. We have build, deploy, staging, integration test, deploy to prod. tests. 3, we have deploy to staging. 4, integration tests. And 5 is deploy to production. The build stage does, look at this. So everything from installing dependencies to make some basic tests. Staging deployment. Using Azure to using to our staging. My pipeline is progressing through 1, a build stage, 2, a build tests, 3, deploying to staging, 4, integration tests, and 5, deploying to production. The build stage does setting up Python, installing tests, etc. The staging deployment does a deploy using the Azure function tools to our staging function app. Cool, so pipeline is running. I think it actually finished. Cool. You'll go through, building tests, deploy to staging, integration tests, deploy to production. If you're having any trouble with any of these, say a single stage deploy or failed, or it's not starting, then you can follow down these. But ours is working, so we'll go on this one. There's a few extra things here that I did. Just accepting the things that pops up with you for permanent access that we have to do. But we should get something that looks like this. And the first time you run it, you'll get this one build and test being quite long. The screenshot was taken the second time I run it as well. Could be 6 or 7 minutes as well. So yeah, it's all good. And we can see, at least the last bit, the job deployed to production environment results exceeded. So we know it's worked all good. So what happens during approval? The approval step is your last chance to catch issues. Before approving, you can test the staging URL, view the code changes, and verify nothing unexpected happened. Cool. So we can go on to Azure and check that. I'm going to log in maybe. We can go to our staging thing and see if that's live. Function app. Click on your backend streaming backend. Production one, not staging one. And then we can go to default domain, I think. Cool. So it's up and running. Good to know. We also put it here and do a open up a terminal and do a Cool, so we see that this is healthy, so good to go. So there's some possible errors here, 404, 500 or a timeout. Some basic steps on how to debug each of these. Definitely reach out to the community or use the ask feature here. Why is this workflow powerful? You just experienced the full CI/CD loop. Every time you push code, the pipeline automatically builds, tests, and deploys to staging, runs integration tests, waits for approval, and deploys to production. This automation means you can ship features faster with confidence. Screenshot of this. I verified my production by curling slash invoke to check the health of the endpoint. Cool. Got the health endpoint returned. 200 success. CI/CD pipeline saved time because no more getting to run tests. Cool. So how did you verify your production deployment? I verified production deployment by curling slash using evoke to check health of the endpoint. The health endpoint returned 200 success. CI/CD pipeline save time because no more feeding to run tests. Cool. Cool. Now we're going to add code quality gates. So just something at the start before even any of this runs, so that we can catch issues earlier. There's something called flake 8 and black, which is things we can put in place at the start to make sure that doesn't happen. The errors don't creep up and waste our time when they get caught later on. So Google's engineering team enforces strict code standards. Every line must pass automated linters before it can be merged. This isn't about being picky, it's about maintaining code that hundreds of engineers can work on without stepping on each other's toes. In the secret mission, you add the same capability. Your pipeline will automatically check code quality and fail fast if standards aren't met before wasting time on tests and deployment. So in the secret mission, get ready to add code quality stage to your pipeline. Run flake 8 to catch Python errors and style issues. Run black to enforce consistent code formatting. Test the quality gate by intentionally breaking the rules. What are we adding to the pipeline? In the secret mission, I'm adding code quality checks. Flake 8 catches. Python errors and style issues. Enforces consistent code formatting. Why code quality matters. Without quality gates, code bases slowly accumulate technical debt. Small issues that compound over time, a missing import here, inconsistent formatting there. Eventually the code base becomes hard to read and maintain. Quality gates catch these issues automatically, at least most of them. So that's flake 8 and black. So our goal is to fail fast, fix fast. By running quality checks first before test and deployment, you get feedback in seconds instead of minutes. If your code has a simple formatting issue, why wait for tests to run? The pipeline fails immediately, you fix and move on. Cool. So we're going to open Cursor, we'll send off this prompt to update our YAML file. What do these tools check? So flag 8 with that checks critical errors only, syntax errors, formatting, assertion issues, undefined names. These bugs crash your code. Black -- check verifies your code follows consistent formatting rules. It doesn't change anything, it just fails if formatting doesn't match. So now we're going to update the build stage dependency. Make sure your build stage now depends on code quality. So we can see, I think Cursor might have added that. We're going to look a close look. Cool, so Cursor added that, so that's useful. This ensures the pipeline runs in order, code quality first, and everything else. Cool, so now we'll push and test. Cool, so we should see something happen. We'll start here. So this is before it's building and testing, it's just checking the code quality, which is really cool. So we should be able to see pretty soon if our code quality passes or fails. Cool, so that code quality thing is passed, so we can go down this pathway. But either of these fail, there's steps here to run these to fix the errors that it's brought up. So now we'll just run. We'll just run. So what you've built, your pipeline now has 5 stages of protection: code quality, build and test, deploy to staging, integration test, deploy to production. So once it finishes, I won't wait for this pipeline to finish, but once it finishes, we'll see the same thing as we see here. So that's really cool. Screenshot this. Zoom out a bit. How do code quality gates improve your pipeline? My pipeline now has code quality gates, 5 stages code quality gates. Catches, basic formatting and styling issues before the build and test and all later stages. This means bad code is found and fixed fast. Cool. So how do code quality gates improve your pipeline? My pipeline now has 5 stages. The first being code quality catches. This catches basic formatting and styling issues before the build and test in all later stages. This means bad code is found and fixed fast. Cool. Quality culture. The code quality gates do more than just catch bugs. They establish team standards. When everyone's code goes through the same checks, you get consistent, readable code that any team member can understand. Google, Microsoft, and any major tech companies enforce similar standards. Now you do too. Cool. So we're going to just do a cleanup. So the Azure DevOps project and pipeline configurations portfolio where they were, consider keeping it to showcase your CI/CD skills to employers. You can always delete it later if you change your mind. So the resources to delete or to manage are the DevOps project and pipeline, the production and staging function apps, the self-hosted agent, and local project files. So if you want to keep everything running, you can go down this route. You want to stop, but keep the resources. Some instructions here. And if you want to delete everything, there's also some instructions here. Yeah, but we'll just go down the keep everything route for now. Cool. So the most valuable thing I learned was adding code quality tests. I can apply this to future machine learning projects. Next, I want to explore GitHub CI/CD projects. Cool. So what were the key tools and concepts you learned in this project? The key tools I used include Azure DevOps, cursor, so YAML, just like pipeline design. Just these key concepts I learned include pipeline design and code quality. How long did this project take you? It took me approximately 1/4 hours. The most challenging part was configuring the pipeline to run without error. It was most rewarding to see my code being deployed in real time. I did this project to learn how to set up an Azure DevOps pipeline. Another skill I want to learn is using GitHub Actions CI/CD pipeline. Cool. The quiz. What is the primary function of an Azure DevOps service connection? Provide secure link for Azure DevOps to authenticate external services like GitHub or Azure. Monitors performance, defines network routing rules. So this one. Why is a self-hosted agent recommended? They require authentication from Microsoft or approval, sorry. What is the primary goal of the CI/CD, project routing CI/CD, to develop a new streaming backend application from scratch, to build a production-grade CI/CD pipeline using Azure DevOps, to integrate AI, to manually deploy. What is the main purpose of a staging environment? To provide a dress rehearsal environment for testing and deploying to production, to serve the primary users, to restore historical versions, to reduce costs. Dress rehearsal. Which file is the Azure DevOps multi-stage pipeline configuration defined? It's Azure pipeline.yaml. I think I might have called it something different. Oh no, it's called that. What is the role of approval gates in the deploy production stage pipeline? To pause the pipeline and require manual confirmation before proceeding with production deployment. That's right to me. project. So I really hope you guys enjoyed. It's a task here, that's why it says it can't complete. How do service connections and approval gates protect production? A service connection allows Azure to connect with external services. An approval gate pauses the deployment at the before production is deployed. This prevents errors from making it to production. Apologies for missing that one. I think that's all of them. Cool. All right. Yeah, I really hope you enjoyed the project. This is a really cool one on Azure DevOps. Yeah, good job getting through it. It's definitely a tricky project. Yeah, I will catch you guys later for another series in 21 and 21.